All right. So today we're going to work through some geometric exercises in using this drafting program. And we're going to start with the absolute most basic things that you can start with and eventually see how it progresses into some really wild stuff. So to begin with, I just have an XY grid here. And I'm going to go ahead and just recreate a little exercise that I did very long time ago, maybe over 20 years ago, of while I was playing around. So this is a 1 by 1 square, and all I do is just draw a circle out to the far corner and draw a rectangle back. And that's it. And that sets up a sequence. And I've already established the pattern and the geometric kind of tool that this is. It's actually a sort of machine, a geometric mathematical machine that we have running here. And so, and some of you might start to see that right out of the gate. But if not, that's all right. I'll do an explanation here in just a second. But I'll go ahead and continue this geometric development here for just a few more iterations. And so it's just rinse and repeat of drawing a circle to the outer corner of the rectangle, and then using that new x-axis line or point that's created by the circle for the next rectangle. And away we go, away we go. And what becomes just visually apparent very quickly, right, is these incremental increases in the rectangle are getting smaller and smaller and smaller. And this will continue on out. So I'm not going to give the explanation yet. I maybe if you're not seeing it yet, I'll step through maybe a couple hints. The first one is I'm going to draw a line exactly 2 inches over. So that's 2 inches. And then let's go ahead and draw one exactly 3 inches over. So that was just sort of dumb luck and I will go ahead and tell you those two hit exactly at those locations. And of course, our first one was 1 inch. So that might start to show what's going on here. So we have a 1 inch distance that the rectangle perfectly hits. Of course, that was the 1 by 1. Then we have a 2 by 1 rectangle that is happening out here, and a 3 by 1 rectangle that's happening all the way out here. Okay, so what did I just do? So this is a very fun little tool to quickly and geometrically create the square root of integers. And so I'll do a quick little explanation here so we can see what's going on. So this is just going back to good old, I don't know, 6th grade algebra here or geometry. So we have the 1 by 1 square. I drew a circle off of it, but the radius of the circle that I drew is this diagonal. So I'm using this diagonal in the geometric creation. And this is a right triangle, right? So that's a 90 degrees. And so we can use this equation for the length of the sides of a right triangle, a squared plus b squared equals c squared. In this triangle, we have 1, 1, and an unknown. What is c, right? So we simplify 1 squared plus 1 squared. 1 plus 1, 2 equals c squared, and I take the square root of each side. And now we can see that c, that diagonal I'm using for the new circle, is the square root of 2. Interesting. So if I just grab the square root of 2, we can see, well, that this was the diagonal right here. That is the square root of 2. And I use that as the circle, and so that distance is the square root of 2. And what that then does is it makes a new triangle. And again, that's a right triangle. All right. And except now the sides are, we still have the vertical as 1, but the bottom leg is the square root of 2. And then what is this leg? So let's see. Did I solve that for us? I don't. Let's look right here. So yeah, so here we go. So this is, well, I'll go ahead and bring those up to our geometric creation. Here we go. Okay. So the length of the bottom leg now is the square root of 2. The height of the leg of this triangle is 1. And we do the same equation. 1 squared plus square root of 2 squared is 1 plus 2 equals 3 equals the square root of c. So this is the square root of 3. And this just goes on forever. And of course, the square root of 3 is a very strange number, but then when we bring the square root of 3 down, our next creation, of course, is the square root of 4, which is 2. And we can see if I draw this line of 2, that's what we get. So this just endlessly creates square root of integers. And of course, I cheated a little bit, or I didn't really note that, but the very first distance, of course, is the square root of 1, which is 1. So the first distance, the first rectangle is the square root of 1, and then we just proceed all the way up endlessly. And so, of course, I'm using a drafting software to do this, and it makes it very fast and easy to create, but all I'm doing is drawing straight lines and arcs. And so this could easily be done with just a string, a couple sticks and a string on a piece of leveled off sand, and you could do this geometric creation, and you could do this anywhere, and with the only tool being literally being a piece of string. Of course, you're going to start to lose accuracy as you get out into here a little ways, but still, I mean, for me, if somebody asked me to come up with the square root of 13, to do that, I would have no idea how to do that mathematically, and to do it in any other way, I guess the only way I would know how to do it mathematically would be just guessing, right? So I would just have to keep guessing. I'd say, well, it's somewhere between 3 and 4, right? But it would be quite onerous for me to get it to any accuracy. Whereas, let's see, this software is giving me, it out to many decibels of detail. So that's what I'd come up with a very long time ago, and just thought it was a funny, little quirk. But then I had some free time, actually on a summer vacation trip. I was trying to look at how to explain this and do it, and I actually started to look at, instead of the sequence just continuing like that, I actually looked at starting with the triangle and building off of it. So I thought this was a little bit of a cleaner approach to it, although it takes more drafting steps. So in this case, I'm going to use the square root of 2 here. Oh, let me clean that out. So I'm starting with just a triangle, 1 square root of 2 triangle. And I'm going to use this as the leg of the next triangle. So like I said, there's a couple more steps in this drafting program, but I think it'd actually be faster using this with just the string. So I'm going to do my next right triangle off of that angle. So now what I've done is I've done a distance of 1 here. We have the square root of 2 here. And since this is a nice little right triangle, this is the square root of 3. And so Then I'm going to go ahead and continue this sequence. I'm going to reorientate the drafting system to that line, go the next triangle. So this one has this as a square root of 3. This is 1. And so this leg is the square root of 4. And let's check if that's real. So that is a distance of 2. And let's go ahead and just for good measure that's a circle of 1. So we see that we've got the square root of 1 here, and here we have the square root of 2. I mean, we have 2, which is the square root of 4. And so this is basically producing the exact same distances as the previous approach. It's just building on itself in a bit of a cleaner fashion. And so I started playing around with this, and really, I love spirals and Fibonacci series and all that, and golden ratio and things, and have been looking into that for other reasons. And so this really piqued my interest a bit, that I'm really getting into the spiraling happening here. And so I actually went to AI to see what maybe this was, and if there was a record of this. And so what was very interesting is if I had expanded it out a little bit further here, and it's very, very fun shape, very, starting to get a conical, organic shape happening. And what I found with the help of AI is that this is a very known and recorded Greek mathematician named Theodorus had created this exact creation in one of his manuals. It is called the Spiral of Theodorus. And so it is the creation. Each of these legs is the incremental square root of an integer, all the way around. And so, that is, I found that just really fun, that I had just completely by accident and following these little steps had ran across and recreated this geometric proof of doing square root of integers that this Greek mathematician had done in ancient days. So just with of course the cheat of having drafting software. So I love the comparison here that this is creating the spiral versus the more rectangular version that goes out here, but it is generating these same distances. So I'm going to stop it there for now. There's a whole forward sequence of things to do with these as well, but I think that's a lot of fun to see how I ran across that just completely accidentally. Thank you.